Welcome back to the deep end. Usually when we say we have a stack of research, we have a few articles, maybe a book summary. Today, well, today is different. I'm looking at this pile of papers you sent over, and honestly, it looks like a syllabus for some kind of PhD program that mashes together quantum mechanics, neuroscience, and ancient philosophy.
It is a bit heavy, I'll admit that, but it's heavy for a reason. We aren't just looking at a single study today. We're looking at a convergence. It's one of those, those rare moments where you see completely different fields, physics, the study of motor control, abstract logic, all crashing into the exact same realization.
That realization is basically the structure of reality itself.
Essentially, yes. We're trying to hand you, the listener, a kind of Rosetta Stone for reality. Now, that sounds incredibly grandiose, I know. But the central idea we're exploring today is that the way the universe is built at the most fundamental level, literally how electrons communicate, seems to follow the exact same mathematical structure your brain uses to construct a thought.
See, that is a massive claim, because usually when people try to mix quantum physics and consciousness, it just turns into this woo-woo magic energy stuff. But the research here is mathematically rigorous. It's all grounded in gauge field theory.
Right. No magic today. Just math that feels a lot like magic.
Okay, so the hook here, the one sentence that really jumped out at me from the prep notes is this one. What is symmetry internally to a mechanism appears as invariance to the external. Now, I read that 5 times. I felt like I was reading a riddle carved on a tomb in an Indiana Jones movie. It sounds incredibly profound, but I have almost no idea what it actually means.
It is dense. But unpacking that single sentence is our mission for this deep dive, because if these researchers are right, understanding that sentence is the key to understanding why you think the way you do. It explains why some ideas like justice or truth can survive for thousands of years, while others like, say, I'm hungry, disappear the moment you eat a sandwich. It's all about the structural integrity of an idea.
Right. So we are going from the behavior of subatomic particles all the way up to the architecture of the human mind.
Exactly, from the quantum to the cognitive.
Welcome to the deep dive. I'm Satosha.
And I'm Satoshi.
So if you're listening and thinking, I have no idea what a gauge field is, don't worry, neither did I until about 48 hours ago. But we're going to walk through this step by step. And it seems like we have to start with this core concept of invariance. That word seems to be the linchpin holding all of this together.
It is. Invariance is really just a fancy way of saying stability or constancy. It's the thing that stays true even when all the little details around it are changing. You can think of it this way. There's a fundamental tension, both in the universe and in your own mind, between the mechanism, all the internal gears and machinery, and the appearance, or what we actually perceive and experience.
The analogy that helped me visualize this was the clock. That was a really good starting point.
It's a classic example, yeah. Imagine a clock on the wall. You look at it and you see the time. Let's say it's 12:00. That's the data. That is the appearance. But behind the face of that clock, there's a mechanism.
Right. And it could be anything. Maybe it's a beautiful set of brass gears. Maybe it's a battery in a tiny quartz crystal vibrating. Or maybe, it's a tiny hamster running on a wheel.
Exactly. And as the observer, you don't care about the hamster. You don't see the gears. All you care about is that when 1 minute passes in reality, the minute hand moves 1 tick. You care about the result. The time displayed on the face is the invariant. It doesn't change, even if I secretly swap out the brass gears for plastic ones, as long as the new gears turn at the same rate.
So the mechanism has a ton of freedom. It can be built in 1,000 different ways. It has redundancy. But the appearance, the time, has to be rigid and consistent.
Precisely. The mechanism has what we call internal redundancy, or symmetry. There are many ways to build a working clock, but there's only one way to tell the correct time. The central argument in these papers is that this very relationship, internal freedom leading to external stability, is the secret sauce of existence. It's how an electron works, and it's how your mind forms a stable thought.
Okay, I can get my head around a clock. But the papers jump pretty quickly from clocks to gauge symmetry in physics. And this is where things get a little slippery. I want to slow down here because I really feel like if we don't nail this part down, the stuff about the brain later on won't make any sense.
Agreed. We have to eat our vegetables first. We have to do the physics.
So let's define symmetry. To me, and I think to most people, symmetry is a butterfly. The left wing looks like the right wing, or a face, being symmetrical.
And that's geometric symmetry. That's a great starting point. But in physics, specifically in this context of gauge theory, symmetry means something a little more abstract. It means immunity to change. It means you can do something to the system, transform it in some way, and the system fundamentally doesn't care. The laws of physics that describe it don't change at all.
Okay. Give me a simple physical example.
Let's take a spinning top. You get it spinning perfectly on a huge, smooth table. It's spinning right there in front of you. Now imagine you carefully pick it up without disturbing its spin, and you move it 3 feet to the left. Does it spin any differently over there?
No. I mean, assuming the table's perfectly smooth and infinite, it just keeps spinning exactly as it was before.
Right. The laws of physics governing its angular momentum didn't change just because you moved it from coordinate x to coordinate y. That is a translational symmetry. The physics is invariant. It stays the same regardless of its location.
That seems, well, kind of obvious, doesn't it? If physics changed every time I took a step to the left, the universe would be an absolute nightmare.
It would be total chaos. But that obviousness is actually a profoundly deep constraint on how reality is allowed to work. Now, we have to go a level deeper. That was an external symmetry, moving the whole object through space. Now we have to talk about internal symmetry. This is where we dive into the quantum world.
The electron?
The electron. Now, we all have that picture in our heads of an electron as a tiny little blue ball orbiting a nucleus. That's the Bohr model. And it's wrong. In quantum mechanics, an electron isn't a point. It's a wave function. It's a smear of probability described by a mathematical function.
Right, the Greek letter psi.
Exactly. Now, this wave function is what's known as a complex number. And for our purposes, all you need to know is that complex numbers have 2 parts. A magnitude, which is like its size or strength, and a phase, which is like an angle or a direction.
Okay, hold on, phase. I need a visual for that.
Imagine that every single electron in the universe has a tiny, invisible dial attached to it, like a little clock face. Not a real clock, but a mathematical dial. The hand on that dial can point to 12 or 3 or 6 or anywhere in a complete circle. That direction it's pointing, that's the phase.
Well, can I see this dial? If I build a powerful enough microscope, can I look at an electron and see where the hand is pointing?
No. And that is the absolute crucial catch. It is completely unobservable. The only thing you can ever measure in the real world is the magnitude of the wave function, which tells you the probability of finding the electron at that spot. The phase, the position of that little dial, is hidden information.
So it's just like the gears inside the clock. It's the internal machinery I can't see.
It is the perfect analogy. It's internal machinery. Now, here's the symmetry. I can take that internal dial and rotate it. I can turn it 90 degrees. I can turn it 180 degrees. As long as I do it, the physical reality doesn't change one bit. The probability of finding the electron stays exactly the same. The math works out that the phase cancels itself out when you calculate probabilities.
So if I were God, and I snapped my fingers and rotated the phase of every single electron in the entire universe by, say, 45 degrees?
Nobody would ever notice. The universe would keep ticking along exactly as before. The laws of physics are invariant to that change. That is a global internal symmetry. You change the hidden internal label of everything everywhere all at the same time by the same amount.
Okay. I'm with you so far. We have a hidden dial. We can turn it. And as long as we turn all of them together, everything is fine. But, and I can feel the plot twist coming. We don't always want to turn it for everyone, do we?
No. This is the radical, brilliant shift that gave birth to modern particle physics. Physicists in the mid-20th century started asking, what if I want local freedom? What if I want to change the phase here in this room, but not change it in London?
I want to set my own standard locally. I don't want to have to call up the whole universe to coordinate.
Right. I want to be able to rotate the electron's dial at point A by 10 degrees, and at the same time rotate the one at point B a centimeter away by 50 degrees. I want the freedom to choose my gauge, my internal measurement standard locally at every single point in space and time.
And that breaks the universe.
It breaks everything, and it's really important to understand why it breaks it. Physics, at its core, is built on comparing things from one place to another. To know how fast something is moving, you have to compare its state at point A to its state at point B. You use derivatives. You measure the rate of change.
Okay, that makes sense.
So imagine you and I are trying to measure the slope of a mountain, but you're using a ruler where an inch is defined as the length of your thumb, and I'm using a ruler where an inch is the length of my foot. That's already a problem. But now, imagine that as we walk up the mountain, our rulers are constantly and randomly shrinking and expanding. Your inch is different at every step you take.
We couldn't compare our measurements at all. It would be meaningless.
It would be impossible. If I say, from my perspective, the mountain went up 5 inches here, and you say, well, it only went up 2 inches for me, we have no idea if the mountain's height actually changed or if our rulers just warped. The derivative, the slope becomes gibberish.
So if the internal phase of the electron, that little dial, is shifting randomly from point A to point B, we can't compare the wave function at those 2 points. The whole equation just falls apart.
Exactly. The Schrödinger equation, the fundamental equation describing the electron, relies on being able to compare these values smoothly across space. If you introduce this local chaos changing the dial everywhere differently, you completely destroy the mathematical foundation of physics.
So nature has a problem. It wants to grant this principle of local freedom, this local gauge symmetry, but doing so breaks the consistency of the universe. It breaks the invariance of the laws. So what's the solution?
It cheats, or, more elegantly, it invents a patch, a fix. To solve this problem, nature is forced to introduce a new field into the universe, a connection field.
Connector.
Let's go back to the mountain with our crazy shrinking rulers. To make our measurements work, what would we need? We would need a conversion table. We'd need something that tells us, okay, when you moved from point A to point B, your ruler shrank by 10%. So you need to add this correction factor to your measurement to make it comparable to your friends.
We need a currency exchange rate that changes at every point, telling us how to translate my foot inch into your thumb inch.
Yes, that is a perfect way to put it. This new field does exactly that. It exists for one reason and one reason only, to compensate for the arbitrary changes in the internal dial as you move through space. It connects the disparate local choices of gauge so that the physics remains invariant overall.
And this connection field, in the case of the electron in its phase, this isn't just some abstract math trick. This field is real.
No. And this is the part that honestly still gives me chills every time I think about it. When you do the math, when you write down the equations and ask, what kind of field do I need to invent to fix this phase problem? What properties must it have? The answer just pops out. You find that you need a vector field. You need a field that interacts with electric charge. You need the photon.
Light.
The electromagnetic field. The entire electromagnetic force. The reason magnets stick to your fridge, the lightning in a storm, the very light from your screen hitting your eyes right now, all of it exists because the universe demanded that the electron have the local freedom to change its internal phase arbitrarily.
That is completely wild. You're saying the force isn't fundamental. You're saying the force is just the cleanup crew that makes the math work.
In this framework, yes. The force is the shadow cast by the system's absolute need to maintain consistency despite all these internal degrees of freedom. The force exists to keep the invariance intact. If there were no internal freedom, if that phase dial was locked in place for every electron forever, there would be no need for a connection field. There would be no light.
So to go back to that original sentence, what is symmetry internally to a mechanism, that's the freedom to change the phase locally, appears as invariance to the external, and that appearance, the thing we feel, is the force.
Exactly. The force is the curvature that naturally arises when you try to lay down a consistent grid on top of all these different incompatible local viewpoints.
But wait, hold on. You're saying the force is just a shadow or a correction. That feels dismissive. If I stick my finger in a light socket, that shock doesn't feel like a mathematical abstraction. That feels extremely real. How can it be just a byproduct of our description?
And that is the huge philosophical debate at the heart of theoretical physics. The physicist David Tong, for instance, argues that gauge symmetry is really a redundancy in our description. He's on the side that says the potentials, the internal dials themselves, aren't physically real. They're just artifacts of our clumsy mathematical language.
Like we have too many variables in our equation.
Right. We're using a language that's bigger and more flexible than the universe it's describing, so we have to invent these forces to cancel out the extra meaningless freedom our own language introduced. That's the redundancy view.
But the other side, the invariance view, says what?
It says that the relationship is the only real thing. The charge, the field strength, those are the invariants. The electron's phase might be a convenient fiction, but the connection between electrons, the photon, the light, is the reality that emerges from that demand for freedom.
Okay. My brain is definitely starting to stretch.
Yeah.
But you promised me this wasn't just a lecture on quantum electrodynamics. You said this same structure explains why I get into arguments with my friends or why political ideologies form.
It does.
Yeah.
Because this architecture, this tension between internal redundancy and external invariance appears to be universal. It turns out your mind is built like a gauge theory.
Mind is a gauge field. Okay, let's pivot. Let's get into the cognitive science.
Let's apply the exact same template. In physics, we had the internal symmetry, the hidden, unobservable phase dial of the electron. In the mind, what is the hidden internal thing that has a massive amount of redundancy?
Thoughts, or maybe the words we use for them. Language.
It's the relationship between meaning and language. Think about a simple core concept. Hunger. That is the biological reality. That is the invariant need. But how many ways can you express that, either to yourself or to someone else?
Oh, wow. Huh. I'm hungry. I need to eat. My stomach is growling. Let's go get some tacos.
I'm famished. I'm absolutely starving. I could eat a horse. You have literally thousands of ways to phrase it. You have a huge internal symmetry. You can rotate the language dial. You can swap the words, change the syntax, use a metaphor, speak in a different language entirely.
But the external invariance, the core meaning that the listener receives, is the same. They understand that I need calories.
Exactly. The meaning is the gauge-invariant observable. The specific sentence you choose is the gauge-dependent description.
And just like with the electron, we have this massive redundancy. We have way, way more possible sentences than we have distinct core meanings.
Yes. And this is where the map between the two domains gets really specific and I think really powerful. Let's look at the components we just laid out in physics and see what they become in the mind, according to this theory.
Okay. So component one in physics was the gauge field, the photon, the connector that fixes the local differences. What is the cognitive equivalent of the photon?
The researchers argue that the cognitive gauge field is attention, or more broadly, context.
The context. Okay, unpack that.
Think about what the photon does. It compensates for local changes in phase to keep the laws of physics consistent. Well, context is the exact same thing for language and meaning. If you walk into a fancy restaurant with friends and say, "I could kill for a waffle right now," the people around you don't panic and call the police.
Right. Hopefully not.
And why not? Because the context, the restaurant, the friendly conversation, the time of day acts as the connection field. It tells the listener, hey, his local linguistic gauge is set to casual hyperbole. You need to apply a correction factor to understand the invariant meaning, which is he strongly desires a waffle. The context aligns our different internal reference frames so we don't catastrophically misunderstand each other.
So when context fails, that's like the derivative breaking down in the physics equation.
Precisely. If I send you a text message that just says, "I hate you," with no emoji, no prior conversation, no context, you have no idea what my local gauge is set to. Am I joking? Am I quoting a movie? Am I furious? The measurement breaks down. You can't compare my intended thought to your interpretation.
That makes perfect sense. Okay, next component. What about global symmetry? In physics, that was changing everything everywhere all at once.
In the mind, global symmetry is universal truth, or pure logic. Think of the structure. If A, then B. That logical structure holds true whether we are talking about mathematics or cooking or fixing a car. If you rotate the entire context, change the subject matter from physics to gardening, the logical structure of inference remains the same.
It's valid in all coordinate systems, so to speak.
Right. If you drop it, it will fall. That's a general principle that's true for a rock, a glass of water, or the stock market after bad news. The abstract form is globally symmetric.
Okay, so then local symmetry.
This is subjective perspective. This is the freedom to view a concept from your specific personal mental angle. You and I can look at the exact same public policy. You might see freedom. I might look at the same set of facts and see anarchy.
The underlying event is the same. The mechanism of the policy is invariant, but our local phase, our interpretation, is different.
Yes. And now for the kicker. In physics, when the local phases don't line up and you try to compare them, you get a field strength, you get a force, you get curvature in the field. What is the mental equivalent of a force?
Cognitive dissonance.
Or surprise. Think about what a physical force does. It pushes, it pulls, it tries to accelerate a particle and correct its path. When your internal model, your chosen gauge, doesn't align with the incoming data from the world, or when my gauge doesn't align with yours, you feel a tension. A mental force.
That physical feeling of, wait, what? Or that jolt of, no, that's wrong.
That is the curvature of your cognitive field. That is the force of meaning. It's your brain demanding that you do something to fix the inconsistency. It exerts a force on you to argue your point, or to update your model, or maybe just to ignore the new data to reduce the tension.
So surprise is just the mind's version of a magnetic field trying to bend the trajectory of our thoughts.
In an ideal system, yes, it's a correction signal.
This all leads to a really interesting concept in the paper called the degrees of freedom of an idea. Because if the mind is a gauge field, it implies that some thoughts must have more symmetry, more freedom than others.
Yes, this is the action space of thought. Degrees of freedom, or DUF, usually means how many independent ways can a system move. In this context, it means something like, how many ways can you transform, rephrase, or recontextualize this idea without breaking its essential truth?
So it's a measure of an idea's robustness or flexibility.
You could even call it semantic entropy. A high DOF idea has a large volume of valid expressions and interpretations. A low DOF idea is very brittle, very rigid.
Let's make this concrete. Give me some examples, because semantic entropy sounds a little academic.
Okay, let's start with a low degree of freedom thought, a very concrete, specific fact. This specific apple in my hand is red.
Okay, this apple is red.
That statement is extremely fragile. It has very few degrees of freedom. It relies entirely on a specific set of coordinates in space and time. If I change the word red to blue, the statement becomes false. If I change this apple to that car, the meaning is destroyed. If I wait until tomorrow when the apple has rotted and turned brown, it becomes false.
It has almost no symmetry. You can't rotate it or transform it in any way without it breaking.
You can't. It only works right here and right now. It is completely gauge dependent.
Okay, now give me a high degree of freedom thought. Something with a lot of symmetry.
Justice is fairness.
Justice is fairness.
Now, watch what we can do with this idea. I can map this onto a dispute between two children on a playground. You got a turn on the swing, so now it's fair that I get a turn. The concept holds. I can map it into a divine theological context. A just God rewards the righteous and punishes the wicked. It holds. I can map it onto a legal contract between two corporations.
I can translate justice as fairness into Japanese or ancient Greek, or even the language of mathematics and game theory.
And the core topology, the essential shape of the idea, survives all of those transformations. It is invariant under transformation. You can rotate the cultural context, the historical time period, the specific language, and the central truth remains recognizable.
This explains so much. It's why we still read and quote Plato, but we don't have any interest in his grocery list.
Exactly. His grocery list was a low DOF thought. Buy 3 olives. That mattered to him on that one day in Athens. It has zero relevance to us. But his ideas about the ideal forms, those are incredibly high DOF. They survive the long, noisy journey through time because they carry their own symmetry with them.
You know, it's funny. We usually tell people to be specific in their communication. We treat ambiguity and abstraction as if they're bad. But what you're saying is that this redundancy, having all these extra degrees of freedom, is actually a feature, not a bug.
It's absolutely a feature. Basic information theory tells us that redundancy is protection. It's what protects a message against channel noise.
Okay, give me an example of channel noise.
Imagine we're talking on a really bad cell phone connection with lots of static. If I'm trying to tell you a password X, 7 capital Q, lowercase p, that is a zero redundancy string of information. If the static makes you miss a single one of those characters, the entire message is useless. It's a very low DOF idea.
Right. Wait, did you say B or P and the whole thing fails?
Exactly. But now imagine on that same terrible connection, I'm trying to tell you a high DOF concept, like I love you, and the static cuts out half the words. You hear, oh,
I can probably still figure it out. The context fills in the gaps. My brain can reconstruct the message.
The gauge field of context compensates for the noise. Because the underlying idea is so robust and has so many possible expressions, you can reconstruct the invariant meaning even from badly damaged data. So in a noisy world, abstract high-DOF thoughts are actually safer and more robust for communication than concrete facts.
That is completely counterintuitive. I always thought that truth with a capital T should be precise, like a laser beam. But you're saying real, enduring truth is more like a floodlight. It's meant to cover a huge area.
A universal truth is a perfect sphere. It looks the same from every single angle you view it from. A concrete fact is like a jagged rock. Its shape changes dramatically depending on where you stand.
Okay, but this creates a massive problem, doesn't it? If we have infinite ways to say, I love you, or as the next section discusses, infinite ways to move our arm to scratch our nose, how do we ever actually do anything? We should be paralyzed by the sheer number of options.
This is the famous curse of dimensionality, and it brings us to the work of Nikolai Bernstein and, much more recently, Carl Friston.
Bernstein was the Soviet physiologist from the early 20th century, right? The guy who studied how master blacksmiths could hit an anvil in the exact same spot every time.
The very same. He discovered what's now called Bernstein's problem, or the degrees of freedom problem. Think about your own arm. You have a shoulder joint that moves in 3 dimensions, an elbow that bends, a wrist that can rotate and flex. You have dozens of muscles. Mechanically, your arm has at least 7 independent degrees of freedom.
Okay. But if my goal is just to touch the tip of my nose,
To specify a point in space, like the tip of your nose, you only need to define 3 coordinates, x, y, and z. So you have a system with 7 variables that you're using to solve an equation that only requires 3.
which means there is no single unique correct answer.
There are infinite correct answers. You can touch your nose with your elbow held high or your elbow held low, with your wrist bent or your wrist straight. So Bernstein asked the brilliant question, how does the brain choose one specific trajectory out of an infinite sea of possibilities? Why don't we just freeze up, endlessly calculating the options?
And the answer from the paper is,
Gauge fixing.
I love that term. It sounds so industrial, so decisive.
It's a term that comes directly from gauge theory in physics. When physicists have too much freedom in their equations, they fix the gauge. They just arbitrarily choose one specific reference frame, one set of coordinates, just so they can get the math done and calculate a concrete answer. In the brain, it's the act of slicing through that massive bundle of possibilities to select one specific expression, one specific action.
So when I'm thirsty and I decide to say the specific words, pass the water, instead of, could you please transfer that container of H2O to me, I am performing an act of gauge fixing.
You are collapsing the wave function of your intention into a single classical action. And the brain has developed incredible shortcuts to do this efficiently. Bernstein called them synergies.
Synergies.
Instead of the brain trying to control every single one of your dozens of arm muscles individually, it links them together into functional groups. It creates a macro command, a single button that says reach. It drastically reduces the dimensions of the problem.
And in language,
Yeah.
the paper makes the connection to things like idioms and cliches.
Yes. Think about a cliche like "it is what it is" or "at the end of the day." Why do we use them so often? Because they are cognitive synergies. They are pre-packaged, off-the-shelf gauge fixes.
So using a cliche is actually a way to save cognitive energy.
It's a way to solve the degrees of freedom problem instantly. You don't have to spend precious energy and time constructing a novel, poetic sentence to express a feeling of weary resignation. You just fire the "it is what it is" synergy, and the job is done.
That explains so much about corporate meetings. We're all just minimizing our caloric burn on gauge fixing. Let's circle back on that. What's the low-hanging fruit? We're not really thinking. We're just executing macros we've all agreed on.
We are efficiently navigating the vast action space of thought. We're being lazy, yes, but it's an evolutionarily advantageous form of laziness.
This connects directly to Carl Friston's free energy principle, doesn't it? We've touched on Friston before in other deep dives. He's the neuroscientist who proposes that the brain is fundamentally a prediction machine.
Right. Friston's framework views the brain as a gauge machine. Its one and only goal, he argues, is to minimize variational free energy, which is basically a mathematical way of saying surprise or prediction error.
The brain builds a model of the world, and it really, really wants that model to match what its senses are telling it.
Yes. But the world is constantly changing. It's full of surprises and perturbations. So when there's a mismatch, the brain has 2 choices. 1, change the world to fit your model, which we call action. Or 2, change your model to fit the world, which we call perception or learning.
And here's the insight from the paper that I found really comforting, actually.
Yeah.
It says that hide-off thoughts act as a buffer zone for surprise.
Exactly. Imagine your internal model of the world, your belief system, is made of brittle glass. That's a low-dose model. It's rigid, it makes very specific predictions. People must always be polite. The trains must always run on time.
And then, inevitably, a train is late, or someone is rude to you in the supermarket.
The glass shatters because the model has no give. It has no internal symmetry that allows it to transform and absorb the shock. You experience a massive spike in free energy, massive cognitive dissonance, massive surprise. You get angry, you get stressed.
But if your model of the world is made of flexible rubber,
If you have a high-def model, something like the world is a complex place, people have bad days, and large-scale infrastructure is inherently fallible, then when the train is late, the model just stretches. It transforms internally. Okay, the train is late, so the invariant goal of getting home is now best served by taking the bus. The overall goal, your calm, is maintained.
so wisdom, or what we call maturity, is essentially a form of cognitive structural engineering. It's the process of building a high degree of freedom internal model of the world that can absorb the shocks of reality without breaking.
Exactly. It's about building a personal gauge theory that is robust and flexible enough to handle the chaotic noise of the environment.
I really like that. It makes the idea of being open-minded sound less like a vague personality trait and more like a concrete survival strategy.
It is the ultimate survival strategy for a complex agent in an unpredictable world.
Which segues us perfectly into the bigger picture of evolution. Why do we even have these kinds of brains? Why do we care about truth? This brings us to segment 5, Truth, Objectivity, and the Philosopher, Robert Nozick.
Nozick wrote a fascinating book called Invariances, and in it, he attempts to redefine the very concept of objectivity, because objectivity is a very slippery word that we use all the time without really defining it.
And he argues that objectivity isn't a property of things out there in the world. It's a property of invariance under transformation.
Right. Let's test it with an example. Is the statement, "I feel cold," an objective truth?
No, because if I put on a sweater, the statement becomes false. If a polar bear walks into the room, it would find the room quite warm. The truth of the statement depends entirely on the observer. It's gauge-dependent.
Exactly. It relies on the specific local gauge of your particular nervous system. Now contrast that with the statement. The molecules in the air in this room have an average kinetic energy of X.
That feels objective. It doesn't matter if I'm here, you're here, or an alien from a lava planet is here. The measurement of the vibration is the same for all of us.
It is invariant under the transformation of the observer. So Nozick argues that the entire goal of objective thought, the whole project of science, is to find statements that are true under the largest possible group of transformations. We try to strip away the gauge-dependent features. We strip away our subjective feelings. We strip away our specific languages. We strip away our cultural biases.
Until only the invariant core remains, the truth that holds no matter who is looking.
Yes. Science is a massive, collective gauge-stripping operation.
But the paper zooms out even further than that. It brings in this wild idea of cosmological natural selection. This is the Lee-Smolin theory, right?
Yes, the physicist Lee-Smolin. He proposed the speculative but fascinating idea that universes can reproduce, possibly through the formation of black holes. And when a universe creates a baby universe, the fundamental laws of physics are inherited, but with slight random mutations.
So universes literally have DNA in the form of physical constants. And the universes whose laws are stable enough to allow for the creation of lots of stars and black holes, they win evolution.
They reproduce more. They come to dominate the multiverse. But the paper applies the same logic not to universes, but to ideas. They call it mimetic selection.
Which ideas survive and replicate in the harsh, noisy environment of human culture over millennia?
The ideas that are circularly invariant.
Okay, you have to define that. Circularly invariant.
Think about an idea that depends heavily on a specific context. For example, you should vote for Senator Smith because he promises to lower the tax on gasoline in the year 2026. That idea is very specific. It's extremely context-dependent or gauge-dependent.
Right. As soon as the year 2026 passes, or Senator Smith retires, or we all start driving electric cars, the idea dies. It has very low heritability.
It can't travel far in time or space. Now contrast that with an idea like, say, democracy is the worst form of government, except for all the others. Or take a core tenet of a religious text that says, this text is the true word of God, and God is truth itself.
It loops back on itself. The idea provides its own justification.
It creates a closed, self-reinforcing loop. It is invariant because it doesn't depend on gas prices or a specific year. It generates its own validity internally. These high-symmetry thoughts are the ones that survive transmission across generations because they carry their own context with them. They are, in a sense, viral by their very structure.
They're like those armored vehicles in sci-fi movies. They don't need a road because they bring the road with them.
That is a fantastic analogy. They are topologically stable against the noise of history.
Which brings us, finally, to the absolute deep end of the deep end. Segment 6, the circular thought.
The cognitive singularity.
We've been talking about a spectrum of symmetry, of increasing degrees of freedom. The paper asks the ultimate question. What happens if you push this all the way to the limit? What happens if an idea has infinite internal degrees of freedom?
A circular thought is defined as a cognitive state that is invariant under the operation of its own processing.
Okay, invariant under the operation of its own processing. Translate that for me.
It means that the act of thinking about the thought doesn't change the thought, and the thought doesn't lead you to any other thoughts. It just points back to itself, perfectly and endlessly.
The paper proposes 3 candidates for what this circular thought might be, and they range from the completely useless to the dangerously pathological to, well, maybe the divine. Let's start with candidate I, the tautology.
The empty circle, A is A.
Whatever will be, will be. It is what it is.
Mathematically, this statement possesses the full symmetric group. You can replace A with literally anything in the universe, and the statement remains true. A toaster is a toaster, love is love, this political party is this political party. You can never, ever prove it wrong.
But it's completely useless, isn't it? It has no content.
It has zero informational content. Its Shannon entropy is zero. It tells you absolutely nothing new about the world. It is a ghost thought. In the language of physics, it's a pure gauge configuration. It looks like a field, but it has zero field strength, zero energy. It doesn't curve reality in any way.
So it's safe, it's comforting, it's absolute truth, but it's an empty comfort.
It's the identity element of the mind. It's a place to rest, a cognitive ground state, but you can't live there.
Okay, let's move to candidate the second. This one is called the well-rounded truth. This idea comes from the pre-Socratic philosopher Parmenides.
Yes, the ancient Greek philosopher. He wrote this incredibly dense poem about the nature of being, and in it he says that reality is complete on every side, like the mass of a well-rounded ball.
He was a monist. He famously said, thinking and being are the same.
This is the mystic's circle. Unlike the tautology, which is empty, this circular thought is full. It contains all of existence within it. In this state, the very distinction between the observer and the observed collapses.
If the observer is the observed, then there is no external anymore. There's nothing outside the system. It's all internal.
Which means it has perfect, absolute symmetry. There's no external invariance to measure yourself against because everything has been internalized. The map has become the territory.
That sounds like, I don't know, enlightenment, or maybe ego death, or just a state of pure consciousness.
It's a singularity. It is a thought that has gauge-fixed itself into a single point of infinite cognitive density. It's the state of pure being with no doing left.
Wow, okay. That's the mystic's path. Now for the dark side. Candidate third, the anthropic loop, the trap.
This is the dangerous one. This is the cognitive structure of the conspiracy theory. This is the structure of unshakable fundamentalist dogma.
The example given is, the Bible is true because it says so in the Bible. Or, I know I am right because I am one of the chosen ones, and the chosen are never wrong.
The paper calls this a closed time-like curve in logic. It's a logic trap from which it's very difficult to escape.
Why is it a trap? What makes it so dangerous?
Because it creates a disconnected component in your cognitive manifold. Imagine your mind is a landscape. Most of your ideas are connected to the ground. They're connected to reality. They get tested by evidence. If I have the belief it's raining outside, I can test it by looking out the window. If it's dry, the belief is falsified and dies. It's connected.
But the anthropic loop.
It floats in the air, disconnected from the ground of evidence. It spins on its own axis, generating its own justification. Take the belief, there is a vast global conspiracy trying to undermine me. If something bad happens to you, that's proof of the conspiracy. If something good happens to you, that's just them trying to lull you into a false sense of security. Also proof of the conspiracy.
So it interprets every possible data point, even contradictory ones, as confirmation of itself.
Exactly. It has infinite explanatory power, but zero predictive power. It can never be falsified, because any evidence presented against it is reinterpreted as part of the conspiracy.
The paper uses a powerful analogy for this. It compares this kind of thought to a black hole.
It is a cognitive black hole. Information from the outside world enters it. You interpret everything through the lens of this belief, but nothing ever escapes. No light gets out. You start making predictions about the world that could be proven wrong. You stop interacting with reality. You only interact with the internal logic of the loop.
That is genuinely terrifying. Because on a smaller scale, we all have these loops, don't we? A thought like, I'm not good enough. That can be a loop. Nobody likes me. That can also become one.
They are incredibly stable structures. That's why they're so hard to break through therapy or self-reflection. They are topologically protected by their own circularity.
So if this circular thought is a kind of cognitive black hole, how do we survive? We can't just live in an empty tautology, and we definitely don't want to get sucked into a pathological black hole.
We have to break the symmetry.
Symmetry breaking. This feels like the final piece of the physics puzzle falling into place.
In cosmology, the early universe was a boring, hot, uniform soup. It had perfect symmetry. It wasn't until the universe cooled and those symmetries broke that things got interesting. That's when particles acquired mass. That's when structure could form.
And in the mind, how do we break the perfect symmetry of a circular thought?
In the mind, we must consciously introduce what the paper poetically calls a Goldstone boson of doubt.
A Goldstone boson. Okay, you have to explain that one.
In particle physics, when you spontaneously break a continuous symmetry, a new massless particle necessarily appears. It's the cost of the break. It's a ripple in the field signifying that the symmetry is no longer perfect.
And in the mind, that ripple, that particle, is doubt.
Or curiosity, or choice, or interaction. We have to
Mhm.
deliberately degrade that perfect, self-contained sphere of Parmenidean truth into the jagged, low-duff shards of everyday decision-making. We have to be willing to say, maybe I'm wrong. Let's check the evidence. We have
Yeah.
to risk being proven wrong in order to interact with the world at all.
We have to voluntarily leave the perfect, frictionless sanctuary of the loop and step into the messy, unpredictable friction of reality.
Precisely.
This brings us to the conclusion of the whole thing. The paper proposes a cognitive Lagrangian.
The Lagrangian is just a fancy term from physics for an equation that describes the total energy and dynamics of a system. The paper proposes that the human mind is a system that is constantly trying to balance two competing terms.
Term number one.
The symmetry term.
This is the part of us that seeks abstraction, that seeks universal, invariant, circular truths. It's the drive to find a theory of everything. We want to find peace. We want to compress all the messy complexity of the world into a single, beautiful, elegant equation.
And term number two.
The interaction term.
This is the part of us that just needs to survive in the here and now. We have to break that beautiful symmetry to make specific, messy, low-dough decisions. Eat this berry, not that one. Turn left at the light, not right. Say this sentence, not that one.
So the entirety of conscious thought is just the dynamic tension between these two drives.
Always. If you have too much symmetry, you become a monk in a cave, lost in meditation, or you get trapped in a tautology or a conspiracy theory. You are disconnected, you have no mass, no interaction with the world.
And if you have too much interaction,
You're just a chaotic mess of stimulus and response. You have no core values, no stable principles, no coherent self. You're just a leaf blowing in the wind of sensory data. You are all force and no stable gauge.
the cognitive Lagrangian is the lifelong struggle to find the balance. It's about navigating the dangerous territory between the chaos of infinite freedom and the spaces of the perfect circular thought.
That is the human condition in a nutshell. We are perpetually stuck between the black hole and the hurricane.
So to try and wrap this all up, at the end of the day, thinking is a gauge theory.
It really looks that way.
Yeah.
We maintain a stable perception of reality by constantly manipulating our internal representations. We use the redundancy of language to protect our thoughts from noise. We use context as a field to connect them.
And the force of meaning, that jolt of aha, or that uncomfortable feeling of, wait, that's wrong, that's just the connection field in our minds doing its job. It's the glue holding our diverse mental states together.
It's the shadow cast by our own internal freedom.
I want to leave the listener with the final provocative thought for the source material. It's a question that has been really nagging me since I first read
A
it.
ground state question.
Yeah. If the circular thought, that state of infinite internal symmetry and zero action, is the true ground state of consciousness, a sort of cognitive vacuum, then is the goal of enlightenment to achieve that state, to become that well-rounded ball of Parmenides, to finally stop the clock?
Or is the goal of life the exact opposite? Is it to constantly and courageously break that symmetry? Are we designed to seek the quiet peace of invariance, or are we fundamentally designed for the productive friction of reality?
Are we here to become the black hole, or are we here to be the Hawking radiation that manages to escape it?
That's the question, isn't it? And I don't think any amount of mathematics can answer that one for you.
No, I don't think so either. But it gives us a hell of a new way to think about thinking itself. Something to mull over the next time you find yourself defending a belief that feels just a little too perfect, a little too self-justifying. Maybe check your symmetry. You might be in a loop.
And check your gauge fixing.
Thanks for diving deep with us. We'll see you in the next one.
Stay invariant.
Or don't. Go break some symmetry.